The Astec double barrel is a counterflow dryer and a continuous mixer section designed to perform efficient drying followed by thorough mixing. The inner drum is constructed of a large rolled metal plate forming a long cylinder. Formed metal flights attached to the internal surface of the drum to prepare aggregates to be mixed with other ingredients required in the mix. 2 solid steel tires are attached to the rotating inner drum by means of leaf spring-type spokes. 4 trunnions with extra-large railroad car-type bearings support the drum, and 2 thrust rollers keep the drum in place. Virgin aggregate in correct proportions enters the inner drum through a gravity chute outfitted with a flop gate to restrict air entry. The inner drum contains 3 zones, with flights designed for a specific function. Conditioning flights at the inlet end break up any clumps or sticky material. Showering or veiling flights lift and pour the material evenly through the hot gas stream, transferring heat to the cooler, moist aggregates. Material dams assure the showering flights are full to maximize heat transfer to the material veil. Combustion zone flights prevent aggregate from impinging on the flame while spreading the material to maximize radiant heat transfer, as well as to protect the drum shell from damage that can occur from the high temperatures generated by the burner flame in this region. Once heated and dried, the aggregate leaves the drying chamber and enters the insulated mixing chamber. At this point, an infrared sensor measures the temperature of the hot aggregate and sends data to the burner control for automatic adjustment of the burner output. The target temperature for the virgin aggregate will be adjusted relative to the volume of wrap that will be introduced to the outer drum. The hot aggregate transfers heat to the wrap in the outer chamber, driving off moisture as steam. This minimizes emissions because the wrap does not contact the hot gas stream in the dryer chamber. The steam and blue smoke from the mixing chamber are pulled into the inner drum past the burner flame, where the hydrocarbons, or blue smoke, is incinerated. This results in a clear, odor-free stack. The only visible emissions are a steam plume on a cool day, even at 50% wrap. An insulated outer shell promotes efficient use of otherwise fugitive heat from the drying section. The use of the conserved recovered heat from the drying section of the drum translates into fuel savings. The insulated outer drum provides a long mixing chamber where mix ingredients are added to the hot, dry aggregate in an order that allows better temperature equalization and more even distribution of all particles throughout the mix. The double barrel utilizes a sequential mixing order. First, hydrated lime is added when required by spec or mix design, followed by recycled asphalt pavement, known as RAP. Then, liquid asphalt cement, or AC, baghouse fines, and finally, dry additives. The mixing chamber includes rows of mixing paddles mounted on the outside of the rotating dryer drum. These paddles ensure thorough coating of the aggregate. Nyhard paddles mounted to the outer surface of the drum convey and mix the heated aggregate with RAP, AC, and dust. Nyhard belly liners provide a wear-resistant surface for the mix to slide across as it travels through the mixing chamber to the discharge chute. The paddles convey the mix to a sweep-type discharge chute, where it enters a drag conveyor or bucket elevator for transfer to a surge bin or storage silo. The discharge chute includes a weighted flop gate to limit air entry. A temperature sensor at the discharge point signals the mix temperature to the control system.